Alright. Good afternoon. So let's continue on Freudenstein method. So we have done function generation for 4-bar mechanism. We would like to design a synthesis mechanism such that it generates this given data. But in this method, the three choices that we pick were beta 1, 2, and beta 1, 3. But in some problems like this ladder, we would like to design a mechanism, a 4-bar mechanism. Ground, link number 2, link number 3, and link number 4. We would like to design this such that when theta 1, 2 is this angle, T1, 2 moving by this angle. And when theta 1, 3 is this angle, T1, 3 is this angle. And also we would like to have Phi1 at 180 degrees at the starting point. So we would like to have Phi1 equals to 180 degrees. This is the constraint on the problem. So if we want to get this, we should play with the beta 1, 2, and beta 1, 3, try the different numbers to get 180 degrees, which is difficult to catch that. So for these types of the problems, when Phi1 and theta 1 are interested, we are going to pick three choices: theta 1 and Phi1, and then beta 1 and beta 1, 2, and beta 1, 3 are going to be calculated. So for a 4-bar mechanism, we are going to do the same. We are going to solve the same problem. We are given with, for example, theta 1, 2 equals to 30 degree, Phi1, 2 would like to be 90 degree, and theta 1, 3 is 45. They would like to have Phi1, 3, 120 degree. The problem has not been changed, but we are interested to have a specific value for theta 1 and Phi1. So when we did the 4-bar mechanism analysis, we could get this equation. We worked on that, and we end up to this equation. We call it Freudenstein equation. So K1 cosine of Pi minus K2 cosine of theta I plus K3 equals to cosine of theta I minus Pi. And K1 is B over A, which is 1 over A. K2 is D over C, which is 1 over C. And K3 is A squared plus C squared plus 1 minus B squared 2AC. So we have three precision points. So for all 3 precision points, this equation should be satisfied. So it should be valid. So I start with the first precision point. My free choices are theta 1 and phi 1. So the first equation is going to be k1 cosine of phi 1. I know that minus k2 cosine of theta 1 plus k3 equals to cosine of theta 1 minus phi 1. First precision point. Second precision point, phi is going to change to 2, phi 2, theta 2 minus phi 2. What would be the theta 2? Theta 2 would be theta 1 plus theta 1, 2. Theta 1 is free choices, theta 1, 2 is given. So I'm going to have k1 cosine of phi 2 minus k2 cosine of theta 2 plus k3 equals to cosine of theta 2 minus phi 2. And last precision point is going to be k1 cosine of phi 3. Theta 3 is going to be theta 1 plus theta 1, 3. This is the free choice. Theta 1, 3 is given. So the angles are so we get 3 equations. These terms are now, we can calculate them. The only unknowns are k1, k2, k3. So 3 equations, we are solving for these 3 unknowns. In a matrix form, if I assemble in matrix form, this is the coefficient matrix, this is my variable, and right hand side will be the constant. K1, K2, K3 is coming here. First equation, what is the coefficient of K1? It's a cosine of theta. What's the coefficient of theta 1? It's coefficient of K2 is coming negative cosine of theta 1. And K3 has the coefficient of 1. Right, for the second equation and third equation, right hand side will be the constant. Solve for K1, K2, K3. After you find K1, K2, K3, A would be 1 over K1. C would be 1 over K2. You plug in A and C here, K3 is given, solve for B. B squared would be 2AC K3 A squared plus C squared plus 1 minus 2AC K3. So you find A, B, C, and D is 1. So you are done with design or synthesis of the mechanics. So for this problem that I have here, if I pick free choices theta 1 and phi 1, theta 1 is 40, phi 1 I pick 60. You can pick any value for theta 1 and phi 1 based on your desired angle. And then theta 2 would be theta 1 plus theta 1, 2, which is 40 plus 30, 70. Phi 2 is 90 plus 60. Theta 3 is 40 plus 45. And phi 3 is 120 plus 60, 180. I'm gonna solve for K1, K2, and K3 by using the MATLAB or your calculator. You come out with K1 equals to 0.291, K2 is negative 0.871, and K3 is 0.128.
Why is there negative?
I'll talk about that. I'll explain. You may get negative values, but you cannot have length as a negative. So K1 is 0.291. If you flip that, I mean 1 over 0.291, A would be 3.44. C would be negative 1.15, and B is A squared. B squared would be A squared plus C squared plus 1 minus 2AC. K3, if I square that, if I apply square root, I will get B value. B is going to be 3.89. So in this problem, we got positive value for A, negative value for C, and positive value for B. So we cannot have negative value for angle. So you start drawing the mechanism. D is 1, so I put D here. O2, O4. The theta 1 is 40 degree. The length of A is 3.4. Somewhere here. B is, Phi1 is 60 degree. So Phi1 is 60 degree. But this is gonna be C, but we got negative value for C. If you got negative value for C, you should rotate this by 180 degree. Instead of moving in this direction, which is positive 60 degree, you should move in this direction by the length of positive 1.15. So if it's somewhere here, C is 1.15. If you connect these two and measure this, it should be 3.89. So this is D, this is angle of 40, A is 3.44. C, this angle Phi1 is 60 degree, but since C we got negative, we are going to move in opposite direction. We end up here. We connect these two. If you measure this, it's going to be 3.89. And if I ask you to draw the mechanism in second precision point, we move the first link, the second link by the angle of theta 1, 2 is 30 degree. It's going to rotate by 30 degree. This link, it's going to move to this direction. And the angle would be, this direction. The angle would be, P12 is 90. So this link is gonna rotate by 90 degrees. It's gonna end up to here. Second precision point, and the third precision point is gonna be the red one. The output link is located on 180 degrees. Question on this. So if I summarize this method, first, as a free choice, choose the suitable value for theta 1 and phi 1. Then, by knowing theta 1 and phi 1, theta 1 is here, phi 1 is this, find theta 2 and theta 3. Because we are given with theta 1 to phi 1 to theta 1 3 and phi 1 3. Solve for k1, k2, k3, and use these equations to find A, B, and C. And then you can sketch the mechanism in the three precision points. All right. Let me work on one example that you are going to work on that as a homework. It's an important example. It's application of the Freudenstein method. You may remember that we talked about when we started kinematic synthesis. I showed you this mechanism as an example for function generation. It's a metering device. So inside the black box, we have a 4-bar mechanism. On the outside, you have these two. You would like to have this desired task. When this guy is at the location of x1, when this is showing x1, this guy would like to show y1. And when it goes to the x1 to x2, you would like this guy is moving from y1 to y2. So we would like to design a 4-bar mechanism such that it generates this desired function for us. So as I said, the correlation between x and y are given, not between theta and phi. In this example, we would like to design a 4-bar mechanism to generate y equals to sine of x. So the x is representing the angle, and the y should represent the sine of x. So we are given with a correlation between x and y. And we would like to design or size the links of the 4-bar mechanism such that it generates this desired function for us. These are the given. The range of input motion should be, and the x should go from 0 to 90. So here in this part, it should start from x not equal to 0. It should go all the way to 90 degrees. So if it goes from 0 to 90 degrees, y, which is sine of x, should go from 0, because sine of 0 is 0, sine of 90 is 1. So it's going from 0 to 1, here it's going from 0 to 90. So when this guy is moving from 0 to 1, we would like to have a range of input motion be 120 degrees. So from this extreme location to the other extreme position, the input link should cover 120 degrees. This angle should be 120 degrees. And the output link should cover only 60 degrees. So delta phi should be 60 degrees. And we would like to have 3 precision points. When x is at 6 degrees, we would like, when it's at 6 degrees, we would like y is showing exactly sine of 6. When x is at 45 degrees, we would like y is showing sine of 45. And when x is at 84, somewhere here, it should show us the exact value for sine of 84. I picked some random number just to show you it can be any desired precision point. So this is what we want to do. Is the problem clear what we are going to design? I didn't provide the correlation between theta and phi. If I had provided the correlation between theta and phi, we are going to back to the Freudenstein method or the first method that we covered in the class. But here I'm given with correlation between x and y. Y is sine of x. So I know the correlation between y and x. What I'm going to do, I know that x is connected to the theta. So x is representing the theta. So I know that these two are connecting to each other. And y is connected to the phi angle. So theta is representing x, somehow phi is representing y somehow. So since I know the correlation between x and y, between these two, I'm going to use this correlation and find the correlation between theta and phi. I'll show you how we can do that. But after we find correlation between theta and phi, we can apply because now we are given with correlation between input angle and output angle, and it's a four-bar mechanism. So this is the idea for this problem. So the solution is not on the slide, so if you want to take a note, you can do it, but I'm going to post the lectures on the videos on the Canvas. So I said we have correlation between x and y. If I find a correlation between, if I connect x to theta and y to phi, then I'm going to use this correlation and connecting theta to phi. So this is what I'm going to do. So I'm going to define scale factor. A scale factor for input motion by k theta, and the scale factor for output motion, which I call it k phi, k theta and k phi. K theta is defined as delta theta over delta x. Scale factor, meaning what would be the range of theta, in this shape it's showing by phi, but I mean the range of theta. The range of theta, we would like to have 120 degrees. This guy should move by 120 degrees. So delta theta is 120 degrees. And at the same time, what would be the range of x? The x, we would like to have this range, 90 minus 0. So it's going to be 120 divided by 90, or 4 over 10. I just defined, I didn't do anything else. So k phi theta, delta theta is going to change to delta phi, and x is going to change to delta y. See what I'm going to do, I'm going to connect x to theta and y to phi. And this is the first step, defining these two scale factors. Phi, the range of motion for the output angle, and the phi, we would like to be 60 degrees. So this guy, we would like to move by 60 degrees. So it's going to be 60 divided delta y. Delta y the correlation between y and x is given. So if x is between 0 and 90, then use this. Y is gonna go between 0 and 1, because the maximum value for the sine is gonna be at 90 degrees, which is sine of 90 is 1, and the minimum value for the sine is 0, which occurs at theta equals 0. So delta y would be 1 minus 0, which is 1. 1 minus 0, the range of y. In different problem, I may get different range for the y, but in this problem, I get 1 minus 0. So 60 divided by 1 can be 60. Not degree, they don't look at the units now. So these two shouldn't have the same unit necessarily, also for K3. Any questions so far? Alright, now next step, I'm gonna find correlation between x and theta and y and theta. So now it's time to pick a free choices. When this guy is at x equals to 0, this is the starting point, what would you like for theta 1? So theta 1 the first point is 0. So what would be the angle of theta 1 when the input link is representing x 0? So this is going to be the free choice. You pick the free choice. Free choice. I pick 96 degrees. I just want to show you it shouldn't be necessary. It can be any number, depends on your interest. At the same time, when it's at x equals to 0, this guy is going to show the sine of this, which is sine of 0, 0. What should be the phi 1? I pick three choices for phi 1 equals to 60 degrees. Let me use theta naught, phi naught, 60 degrees. The reason that I changed 1 to 0 because later on I'm going to talk about 3 precision points where it's going to happen at 6, 45, and 84. So it's going to be theta 1 and phi 1 for first precision point, theta 2 and phi 2 for this, and theta 3 and phi 3 for this. So I just wanted to use theta naught and phi naught for this, and theta 1, phi 1 for the first precision point, and second and the third. So this is, you pick these two, three choices. Now I'm gonna write a key equation which connects theta to x and phi to y. So we can write this, theta I equals to theta naught plus k theta times xi xi minus x naught. Look at the scale factor for input motion. K theta is going to tell me if x is changing by the value of delta x, then theta is going to change by delta theta. Because if you multiply delta x by k theta, you will find delta theta. So this time this is going to tell you how much the input angle is going to change. Now look at here. Xi minus x naught is telling me how much x is different than your starting position. If you multiply this by k theta, it's going to tell you how much you should rotate plus the input angle, which is 96. So you end up to the angle corresponding to xi. So for I equals to 1, x1 is 6 degrees. This is your first position point. Theta 1 would be theta naught, which is 96, plus k theta is 4 over 10, multiplied by x1 is 6. What is the x naught? 0. The starting position is representing the starting point of x, which is 0. 6 minus 0 is 6, times 4, 24, divided by 3, 8, plus 96, 24, 8, 140. So by picking this free choice for theta naught, it tells me when this guy is moving from 0 to 6 degree, x1 is 6 degree, the angle of input link is going to be 114. It's moving from 96 to 140. Second precision point, it's 45. Theta 2 is 96 plus k theta 4 over 10, x2 is 45, x naught is 0. 45 divided by 3, 15, times 4, 60, plus 96, 156. So theta 2, the angle of this input link at the second precision point should be at 156 degrees. And last one, theta 3 would be 96 plus 4 over 10 multiplied by x3 is 84. 84 minus 0. 84 divided by 3 is 28. 28 times 3 times 4, it's 112. 112, 96, 8, 28. Yes.
The first one should be 104, not
114. 6 times 4, 24 divided by 3, 8. Yes, 104. Thank you. Thanks for catch. And this is going to be 208. So now I know that when the input link is moving from 0 to 90, when it's at 6 degree on this guy, the theta corresponding to that should be 104. When it's at 45 degrees, the theta corresponding to that is 156, and when it's at 84, the angle is going to be 208. If I find phi1, phi2, and phi3, then I'm going to have theta 1, phi1, theta 2, phi2, theta 3, and phi3 back into this set of equation. I have theta 1, phi1, theta 2, phi2, theta 3, phi3. I'll solve for theta 1, k1, k2, k3. So for that part, yes.
You said that the theta has to be 120.
This is given by the problem. We would like to have delta theta equals to 120.
Yes, but if I do theta 3 minus theta 9.
Delta theta is 120. So theta naught is 96. If I add it to 120, it's going to be 216. So it's going from 96 to 216. And I didn't pass that.
Okay, so that means we must not pass 120.
Yes,
it's not
the range,
is
no, it's a delta theta. The range is 120. But at any angle that you start here, it should go only by 120 degrees from that. It's not the angle, it's the difference. It's how much you should move. So theta naught is 96. I shouldn't have 216. As you see, at 84 is 208. 84 is very close to 90. I'm sure that if we go by 90, it's gonna be 260. So for phi, we are gonna use similar to this equation. Phi I, just change theta to phi. Phi I equals to phi naught plus k phi. Instead of x, we are gonna have y. yi minus y naught. Same logic. K phi times delta y is telling me how much angle of phi should change. If whatever is the change in y times k phi is going to tell me how much the angle of phi should change. So I'm going to calculate phi 1. It's going to be phi naught, it's a free choice, 60 plus k phi is 60 multiplied by y1. y1 is sine of angle of x at the first precision point, sine of 6. Minus, what would be what would be the value of y at the starting position? At the starting position, we have x equals to 0, y of 0 is 0, so it's going to be 0. This is going to be 0.1045 times 60 plus 60 is 66.27. So when the input link is at the angle of theta naught, which is 96, the output link would be at the angle of 60. When it's moving from 96 to 104, the output link is going to move from 60 degrees to 66.27. Phi2 would be 60 plus k phi, which is 60, times sine of second precision point is 45, sine of 45 minus 0. Plus 60. Sine of 45 minus 0 is going to be this, times 60 plus 60. It's going to be angle of 102.42. Do the same things for phi3. You will get 119.67. Let me check. The angle from 45 is going to change to 84. 119.67, yes. So this, and this. Now we have this problem. When theta 1, not this one, when theta 1 is 104, I would like phi1 be at 66.27. When theta 2 is 102, not 102, 156, phi2 was, should be at 102. 0.42, and when theta 3 is at 208, phi3 should be at 119.67. So now we back to this problem. We are given with theta 1, theta 2, theta 3, phi1, phi2, phi3. With this set of data, set up these equations, this matrix form, and find K1, K2, K3, and design or synthesis the mechanism. In the homework problem, I ask you to do the same problem, just write the code to design the mechanism, but I think I added one criteria, make it crank rocker. So after you find A, B, C, and D, you check the crank rocker. If it wasn't crank rocker, change these two. Change one or both to satisfy the criteria for it. I gave similar to this problem in one exam, final exam. Yes. I just changed the function from y equals to sine of x to something different. It's just gonna change the correlation between y and x, but the approach will be the same. Any question on this? One group can pick this as a project if they want, and design a mechanism to generate the desired function. But we should discuss about the function if any group is interested. Question on this. I have to start the function generation for 6-link mechanism, but I'm going to do it tomorrow. I'm going to post the homework. It's one problem. The due date would be. Do you want to combine this with our last homework and set the due date for December 5th, or you want to have one homework due on 25th Monday, and the shorter homework which is due on the December 5th.
Combine it.
Combine, okay.
Combine it.
It's gonna be more, everybody. It's gonna have 2 coding problems and 2 more problems.
Do you think you can post the homework?
I can, I mean, I
I need
can.
you to post it before the break.
Yes, I'll do it tomorrow.
Oh, okay, so
But I'll set the due date on December 5th.
That's me. Oh, I sent it to you. Oh, good. I like, literally, I like reading the book.
Once
You
upon
read it that fast.
Wednesday.
I sent it to you. I said you didn't look at that too.